Alrighty, folks. Today's topic is going to be dimensional analysis. And dimensional analysis is starts on page 12 in your packets, okay? And we're going to do a whole bunch of stuff with it. So I guess the first thing I need to go over with you guys when I talk about dimensional analysis is I need to talk about what is a conversion factor, okay? So you've been using conversion factors for a long time, okay? And there's a whole list of conversion factors that are in your packet on page 13. It's this entire list right here. But it's things like this. You've known for years that 12 inches equals 1 foot. Or you've known that 365.25 days is the equivalent and equal to 1 calendar year, right? You know, we've been doing these things, 3 feet equals 1 yard, etc., etc. And so this entire page is full of all kinds of stuff. A pound is equal to 16 ounces. A mile is 5,280 feet. There are even complicated things, like, for example, a pound being equal to 453.6 grams. Or how about 1 milliliter is equal to 1 centimeter cubed. And so all these different things are part of dimensional analysis again because they get a name and they're called conversion factors. And we can go from one thing to another using them, and we use this process called dimensional analysis. And I really like dimensional analysis, and the biggest reason I like dimensional analysis is because if we use it properly, what happens with dimensional analysis is we end up being able to cancel out our units so that we're left with the units of the problem that we're trying to solve for. And so I'm going to do a couple of example problems. They're on page 12 at the bottom of the page, and here we go. It says, how many inches are in 3 feet? So the first thing I recommend you start with is a number or some type of value as given in the problem. And in this case, the number or the value we're given is this thing, 3 feet, okay? And so in a dimensional analysis, what we do is we set up a cross that looks kind of like this. And what we do with that is we want to take and we want to cancel out feet, okay? And so what ends up happening here is we need to be able, so just like in math, right? If I wanted to take a 7 out, I would divide it by a 7, and those things would cancel one another. Well, here, if we want to get rid of feet so that we can go to what we're being asked, inches, we got to put feet on the bottom. Okay, so I'm going to put 1 FT, symbolize it. Well, there's a dimensional analysis I put right here, right? Of 12 inches is equivalent to 1 foot. And so what we do is we put that conversion factor right here. And what we do is we put it as a fraction. It's 2 equivalent things. So in 1 foot, there is 12 inches, okay? And what that does for us is it allows us to take feet and divide out feet. They cancel each other. Now this is a pretty simple dimensional analysis in the regard of, you end up with inches right now on the top. But the cool thing about dimensional analysis is just that. You'll end up with what you're looking for on the top at the very end. Now I'm going to make this 3.0, and here's why. Significant figures, okay? So if your packet say 3, I want you to make them say 3.0. That's because I don't want to have to necessarily round this answer and make it weird right off the bat. But what I want you to do is I want you to answer with the number of significant figures as the problem that was originally given to you, or the number. And so this is 1 sig fig, and we're going to make it 0.0, so there's 2. So 3.0 times 12 divided by 1 times 1. So that's what we do. We multiply across. So we end up with 36 over 1, right? Because that's fractions. Fractions, we multiply the top across, we multiply the bottoms across. We get 36 over 1, which is redundant, right? And that is going to be equal to 36. Now we can't forget a very important thing, and that is our label that needs to be placed there. So this is 36 inches. And again, 1, 2 significant figures to match 1, 2 significant figures. I know I manipulated that, but I think it's just a good idea for us to do so. Okay? On the second one right now, here's what I want you to do. I want you to make this 17.000 weeks. So let's go with 5 significant figures. 17.000 weeks. Okay? I'll symbolize that WKS. All right, so the last one was really simple and really easy because we ended up being able to go in one step, right, from feet to inches. But in this one, we can't go from weeks to seconds. At least that's not like a common thing that I keep in my head. But I do keep some things with time. So for example, I know that in 1 week, there are 7 days. And so week cancels weeks, leaving me days. Now that's not what I'm looking for, right? The problem says how many seconds are we gonna have? So I got myself into something, but I'm closer now. And here's how. I know that in 1 day, there is 24 hours. Day cancels days. Again, dimensional analysis helping us. There's a conversion factor, there's a conversion factor. We're still not done because the question or the problem wants us to tell seconds, don't we? So what ends up happening here is we know that in 1 hour, there is 60 minutes. Hours, canceling hours. And we'd have the number of minutes in 17 weeks of school, which also happens to be roughly what you got left in this semester, okay? Now, we have one more thing that we need to do, and that is in 1 minute, there is 60 seconds. Minutes, canceling minutes, right there. Now, we come over here, okay, and it's a coincidence, by the way, that these are all end up being ones on the bottom. We'll do a problem eventually where that won't be the case, okay? But right now, we just end up with 1, 1, 1, 1, 1. So what we do is we take our trusty calculator out. We take 17 times 7 times 24 times 60 times 60, okay? And we get this number, which we're going to do some significant figures with in a second. But that is 1, 0, 2, 8, 1, 6, 0, 0. Okay? Now let's verify the significant figures on it. So 17.00 is 1 sig pig, 2 sig pigs, 3, 4, 5, and that's because trailing zeros are significant. So when I come over here, I get 1, 2, 3, 4, 5, right? And so this is a little bit odd, right? The true answer to this, okay, is 10,281, or 10,281,600, right? But if I want you to make the significant figures match at the end to here, then I gotta go to 5. And so it's kind of a weirdo, but here's how this one would go. We would keep the 1, we'd keep the 0, we'd keep the 2, we'd keep the 8. And then we have to look at what this 6 would do to a 1. It would round that up and make it a 2. And then we went up with 0, 0, 0. And so the significant figures answer ends up being 10,282,000. Okay? And that's one of those times where significant figures kind of drive me crazy a little bit. Okay? You should also know that I'd be marking myself wrong right now. And here's why. I forgot an important thing. I forgot to give my answer a label. So we also need to give the label of seconds. Okay? And that'd be the proper significant figures answer. Though in real life, it's definitely that. All right. I would like everybody to now turn with me to page 14, where I'd like to also do a couple more examples. And then I'm going to set you kind of on your way and say, hey, I hope that you can do a dimensional analysis problem. All right? So on page 14, it says how many inches are there in 45.6 centimeters? So I know my number that I'm given here is 45.6 centimeters, and I want to know how many inches that is. So I flip back to my page 13. And by the way, page 13 will be given to you on all tests and quizzes. I do not expect you to have it memorized. It even has temperature equations on it for those who are concerned about that. And so I go on here and I start looking for some different things. And there's actually 2 possibilities. There is this, 1 centimeter equals 0.3937 inches. but there is also 1 inch is equal to 2.540 centimeters. And what I'm going to tell you is this. You can get to the right answer doing it either way. You might get a slightly different decimal at the very end from me, okay? But I would see your work, verify it, say, okay, and you might get, like I said, you might have a rounding issue at the end. We'll see. I'm going to use the bottom one, okay? So 2.540. Why? Because I want to put something on the bottom that isn't a 0, right? So there's 2.540 in 1 inch. Centimeters, canceling centimeters as dimensional analysis does. Leaving us inches on the top, it's what the problem is indeed asking us for. We come get our calculator out. And now we're going to take 45.6, multiply it by 1, right? So that ends up being 45.6 over, this is a 1, a placeholder. So it's divided by 2.540. Okay? And so when I take 45.6 and I divide it by 2.540, I end up with this number. And I'm not answering with sig figs yet. 17.9527559055. Okay? Now, significant figures. In this number right here, 45.6, because we always do it on our original number, there's 1, 2, 3 significant figures. Therefore, our answer can only have 3 significant figures. So here's how we figure that out. We keep the 1, okay? We keep the, so what we're going to do is we're going to be looking at 1, 2, 3. And so we're going to look at what the 5 does to the 9. Now, this is one time where because the 9 gets rounded up, it compound rounds, but normally it's just whatever the next digit is. And so what ends up being our answer here is 18.0 and the label of inches. Okay, I had to do 18.0. The 5 rounded this up, which then rounded this up. And that's the only time you should compound round. Otherwise, with this, it's just whatever the next digit says impacts the previous one. Just like on the problem we did before this back on page 12. Let's do one more example, all right? So let's see, number 2. Actually, let's not do 2. I'll look back. Let's do 2. All right, so number 2 says how many centimeters are there in kilometers? Now, I'm not sure I would do a dimensional analysis on this problem. I'll flat out tell you I wouldn't. But for now, I will. So 1.23 times 10 to the negative 6 kilometers, okay? So that's negative 6. All right, so I set that in a dimensional analysis, and here's what I know. I know that in 1 kilometer, there is 1,000 meters. Okay? I've learned that kilo equals, it means 1,000. So now I have meters, but I want to go to centimeters, don't I? Well, I'm recalling my meter sticks when I was in, high school and in other places. And in a meter stick, right, a meter stick, so 1 meter, there's 100 centimeters from end to end of it. Now, let's say you were struggling with that. We have a chart, don't we, right? And so what ends up happening is if we wanted to go from milli to centi, right, we would end up going 1, 2 places to the right, right? So 1 with meters, 1, 2 would give us 100, which ends up right there. Okay, so I'm just using our chart that we used earlier to convert from 1 meter to 100 centimeters, okay? So meters cancels meters, giving me centimeters. And then I just do, my math on that. Again, it ends up being something, all right, so I'm going to put in parentheses 1.23 e negative 6 times 1,000 times 100, okay? 1.23 e to the negative 6 times 100 times 1,000. All right. And my answer for this problem, I'm going to cheat, ends up being 0. Not a significant figure, right? 0.1 that this was a helpful video to you, and I hope that you could now complete the remainder of the problems that are on page 14, and maybe you'd be even ready to just go at dimensional analysis all the way. I'm not going to assign that necessarily right away. I'm going to want you to learn a little more about dimensional analysis. If you have questions about this, please make sure you ask them. But again, the whole idea is we want to cancel units. Take care.